Good morning, students. First, we have to revise the third unit. After that, we will go to the new topics. So, in the third unit, multivariable calculus, first topic is evaluation of double integral. First method to solve evaluation of double integral is first one, when y1, y2 are functions of x and x1, x2 are constants. F of x comma y is first integrated with respect to y, keeping x fixed between the limits y1 and y2. And then resulting expression is integrated with respect to x within the limits x1 and x2. Here first we have to integrate with respect to y, because of y is a function in x. So x is constant, so that's why we can integrate with respect to y first. After that we can go to the x, because of x is having constant limits. This one write as double integral f of xy dx dy equal to integral x1 to x2 integral y1 of x to y2 of x. Y is a function in x, f of x comma y dy dx. Second method is when x1 x2 are functions of y and y1 y2 are constants. F of x comma y is first integrated with respect to x, keeping y fixed between the limits x1 x2 and then integrated with respect to y within the limits y1 and y2. Here x is a function in y and y1 y2 are constants. So you can write the integration double integral f of x comma y dx dy is equal to integral y1 to y2 integral x1 of y to x2 of y f of x comma y dx dy. Because of here x is a function in y, so that's why we can write first integrate with respect to x. After that y1 y2 are constants, we can integrate with respect to y. When x1, x2, y1, y2 are all are constants, we can write the integration, or we can find the integration double integral f of x comma y dx dy is equal to first integrate with respect to x, next integrate with respect to y. After that another procedure is first integrate with respect to x, next integrate with respect to y. You can choose any order to integrate with respect to x or y. These three are the methods to solve a double integration. Now we will discuss the example on double integration. Evaluate integral 0 to 2 y equal to x equal to 0 to 3 xy dx dy. In the problem only they are giving the limits to x and y directly. We can integrate first with respect to x, next with respect to y. That is integral y equal to 0 to 2, x integration is x square by 2, limits are 0 to 3 y dy. So here 1 by 2 is constant right outside, and substitute the limits for x. 3 square means upper limit is 3 minus lower limit is 0 into y dy. 3 square 9 value, so 9 right outside, 9 by 2 integral 0 to 2 y dy. Y integration is y square by 2, limits are 0 to 2. Substitute the upper limit 2 square by 2 minus lower limit is 0. So 2 square by 2 into 9 by 2 value is 9. Next example is evaluate integral 0 to 3 integral 1 to 2 xy into 1 plus x plus y dy dx. Now you have to choose integrate with respect to first y and next x, because of I am choosing the order with given integration, that is first with respect to y, next with respect to x by using this dy dx. So that's why I am writing the limits for x is equal to 0 to 3 and y is equal to 1 to 2 xy into 1 plus x plus y dy dx. Now xy multiplying with this function, we get xy plus x square y plus xy square dy dx. First integrate with respect to y, so x is constant, then y integration y square by 2, here also y integration y square by 2, y square integration is y cube by 3. Limits are 1 to 2. Now first you have to substitute the upper limit, that is integral 0 to 3 2x plus 2x square plus 8 y cube value means y equal to 2 cube 8x by 3 minus lower limit. Now lower limit is 1 x by 2 plus x square by 2 plus x by 3, because of y value is 1, y square value is 1, y cube value is also 1. Now you can simplify, separate the x terms and x square terms. Then you can take the LCM and simplify. We can get 23x by 6 plus x square is 3x square by 2. Now you can integrate with respect to 2x. X integration is x square by 2. 23 by 6 is constant. And next term 3 by 2 is constant. X square integration is x cube by 3. Limits are 0 to 3. So now substitute upper limit is 3, lower limit is 0. We get the values are 69 by 4 plus 27 by 2. Take the LCM is 4. We get the solution is 123 by 4. And next problem, evaluate integral 0 to 2, integral 0 to x, y, dy, dx. Previous two problems we are discussed with constant limits, but here the limits are variable limits. So function in x. So that's why the first limits are 0 to x. This is a function in x. So that's why these are the limits for y. The remaining limits for x. So x is equal to 0 to 2 and y is equal to 0 to x. Y dy dx. First integrate with respect to y. Y integration is y square by 2. Limits are 0 to x. Sub 1 by 2 is constant right outside. Integral x is equal to 0 to 2. X square minus 0. So then x square. X square integration is x cube by 3. Limits are 0 to 2. You can substitute 2 cube by 3 minus 0. 1 by 2 into 8 by 3. Answer is 4 by 3. Here we are taking the limits, variable limits. So that's why here 0 to x is considered for y. Y integration y is equal to 0 to x. X is equal to 0 to 2. Next, going to the next problem. Evaluate integral 0 to 4, integral y square by 4 to y. The function is y by x square plus y square dx dy. So here the limits are function in y. So that's why these limits for x. The remaining limits for y. So x is equal to y square by 4 to y by x square plus y square dx dy. First you have to integrate with respect to x. So that's why consider y as constant. Keep it fixed. And we can write the integration for dx by x square plus a square form. Here in the a place we have y is there. So that's why 1 by a tan inverse of x by a is a formula. So then we can substitute a is equal to y. So 1 by y tan inverse of x by y. The limits are y square by 4 to y dy. So then we are substituting the limits for x only. Here y is considered as constant, so right outside y cancel. Tan inverse of upper limit is y by y minus tan inverse of lower limit is y square by 4 by y into dy. Tan inverse of y by y value is 1. Tan inverse of y square by 4 by y value is 4 y by 4 dy. And next we know that tan is 1 at 45 degrees, so that's why tan pi by 4. So tan inverse of y by 4 dy. So tan inverse tan cancel, then we can get the pi by 4. Tan inverse of y by 4. Pi by 4 is a constant right outside, and separate the integrations with the two functions here. Integral 0 to 4 dy and minus integral 0 to 4 tan inverse of y by 4 dx. Here we don't have direct integration for tan inverse x, so it is integrate by parts. So that's why I'm multiplying with 1, and integral dy is y. Limits are 0 to 4. Here the integration 0 to 4 tan inverse of y by 4 into 1 dy. Integrating by parts by using the formula integral u v dx. Formula is u into integral v dx minus integral u dash derivative of u integral v dx into whole dx. So by using that, here u is tan inverse of y by 4, v is 1. So that's why tan inverse of y by 4 integral dy minus integral 1 by 1 plus x square. Tan inverse of x derivative is 1 by 1 plus x square. In the place of x we have y by 4. So y by 4 whole square into y tan inverse y by 4. So now you can write the derivative of y by 4 with respect to y is 1 by 4 and integral dy into whole dy. Limits are 0 to 4. Here upper limit is 4, lower limit is 0, so that's why we can pi by 4 into 4 minus 0. It is pi by 4 into 4 minus tan inverse of integral dy is y, and it is y by 4 whole square is equal to y square by 16. LCM is 16. Write the reciprocal directly. 16 by 16 plus y square 1 by 4. Integration of dy is y into dy integral 0 to 4. So pi minus y into tan inverse of y by 4 minus 4y. Here 4 into y. I'm writing 4y as 2 right outside, 4y right as 2 into 2y, 2 right outside, 2y by 4 square plus y square dy. Why I write like this is we have a formula integral f dash of x by f of x dx is equal to log mod f of x. So by using this formula here, 4 square plus y square derivative is 2y. So that's why we can write f dash of x by f of x formula. Then we can get the answer is y tan inverse of y by 4 minus 2 log of 16 plus y square. 4 square 16 plus y square, limits are 0 to 4. Now you can substitute the limits for y. That is y value is 4, tan inverse of 4 by 4 is 1 minus 2 log 16 plus 4 square is 16. 16 plus 16 is 32 minus lower limit is here, lower limit becomes 2y into tan inverse of 0 is 0 into something 0 minus 2 log of 16 plus 0 log 16. So then we can get tan inverse of 1 is pi by 4, already discussed. 4 into pi by 4 minus 2 log 32 minus of minus plus 2 log 16. So here pi minus pi plus 2 log 32 minus 2 log 16. Pi cancel, 2 common log of 32 minus 16. 2 log of, we know that log a minus log b is equal to log of a by b, log of 32 by 16. We get 2 log 2. Next example is evaluate integral 0 to a, integral 0 to under root of a square minus x square under root of a square minus x square minus y square dy dx. So first limits are constant limits, next limits are functions in x. So that's why these limits are considered as y limits and the remaining limits are x limits. Here the given function write as under root of a square minus x square whole square minus y square dy dx. Why? Because of here first we have to integrate with respect to y. So here y is a variable, remaining all are constants. So that's why I write a square minus x square is one term and write under root of a square minus x square whole square. Why I write like that? It is in the form of integral under root of a square minus x square dx. We have a formula x by 2 under root of a square minus x square plus a square by 2 sin inverse of x by a. So that's why I write this term as under root of a square minus x square whole square. Here root and square cancel, again we get the same function. So that's why I'm writing here like this, and after that I'm applying the formula. In the place of a square, we have root of a square minus x square, and in the place of x, we have y. So that's why we are substituting a is equal to root a square minus x square, y is equal to x. So x by 2, y by 2 under root of a square minus x square whole square minus y square plus under root of a value is root of a square minus x square whole square by 2. Sin inverse of x value is y. Now a value is under root of a square minus x square. Substitute the upper limit is root a square minus x square, lower limit is 0 into dx. You can substitute the limits. We can get the value is first limit becomes to 0 and second one is a square minus x square by 2 sin inverse of 1, and lower limit is y into something 0. So that's why y value is 0. Here we are getting 0, and here also sin inverse of 0 value is 0. So lower limit completely 0, and the upper limit we are getting only one term because of here the same terms are there. So that's why we are cancel the terms, we are getting the 0. Next one is a square minus x square by sin inverse of 1. Sin inverse of 1 value is pi by 2. We know that sin is sin 90 is 1. So that's why we can get the value is pi by 2. So here a square minus x square by 2, 1 by 2 is a constant right outside, and pi by 2 also constant right outside. We can write the a square minus x square dx. So pi by 4 into a square is a constant, integration with respect to x is x minus x square, integration is x cube by 3, limits are 0 to a. So pi by 4 a cube minus a cube by 3, lower limit is 0, obviously we are getting the 0. So pi by 4 into 2 a cube by 3, pi a cube by 6. Next, evaluate integral 0 to 1, integral 0 to x square e power y by x dy dx. So here first limits are constant limits, next limits are 0 to x square. 0 to x square is a function in x, so that's why we consider the limits for y is equal to 0 to x square and x is equal to 0 to 1. All of you know the integration for e power ax integration is e power ax by a. So here we are integrate with respect to first y, so that's by 1 by x is constant here, so that's why e power y by x integration is e power y by x by y by x derivative is 1 by x. We can write it, and 1 by x is constant here, write reciprocal x into e power, we are substituting the limits for y x square by x, and lower limit is 0. You should substitute the 0 also because of e power 0 value is 1, so we get x e power x minus x dx. Again we have to integrate with respect to x. We know the formula for x integration of x e power x dx is equal to x e power x minus e power x, x e power x minus e power x minus, because of x e power x integration is x e power x minus e power x minus, x integration is x square by 2, limits are 0 to 1. So we are substituting the upper limit 1 into e power 1 minus e power 1 minus 1 by 2, minus lower limit is 0, e power 0 minus 0. So e cancel, minus 1 by 2 plus 1, e power 0 value is 1, minus into minus plus. So the answer is 1 by 2. That's all students. Today we discuss about how to find the double integral, first topic. In the next class we will discuss the how to find the limits to the given region.